Hello and welcome to another one of these ADD videos. Today we're going to be looking at t-scores, the fundamental case of t-scores in which sigma is unknown. There are other scenarios such as match pair designs or before and after a treatment or training. Things like that are also t-scores, but they employ different t-score formulas. So in this scenario, if sigma, the population standard deviation, is unknown, then you can get a critical value. This basically is going to dictate whether you reject or keep your null hypothesis. And basically it works like this. Your degrees of freedom will be going down the table, and then your probabilities, your alpha probabilities, actually I think it's 1, 2, 0, then 1, 0. The probabilities are on the top. 0.05. They go that way. So based on what your alpha level is and what your degrees of freedom are, you can get this critical value, and that's going to be also referred to as your chart value here whenever I do the determination of whether or not to reject the null. This is your formula for the test statistics. The test statistic. X bar is the sample mean, mu is the population mean, S is the standard deviation of the sample. If you remember, you probably will be given all this data, but if you got to recalculate it, it's xi minus x bar squared over n minus 1, because it's the sample, not the population, and then square rooted if you want to guess. Just a quick refresher. And the number of observations. And basically what you're going to do is you're going to plug into this formula here, you're going to get a value, and then you're going to compare it to your chart value. Now, I prefer method 1. You just look at the absolute value of your calculated t-score, and if the absolute value of your calculated t-score is greater than your chart value that you looked up, then you reject the null hypothesis. Okay. Method 2 has you doing, if your research hypothesis is less than, then your rejection region is over here, and you put a negative number in front of your t chart value, right? And then that dictates your rejection region, and if it's greater than, you do it on the right side, and so forth. I prefer method 1. It's pretty quick and to the point. Alright, so worst case scenario, you might be asked to calculate these means and the standard deviations. Most likely you'll be given the actual values here to plug in, and you should be able to calculate all of it. Okay, and make a conclusion. So check out the example video. Practice, practice, practice. Thank you, and have a nice day.